So let me kind of break down what um, how I graph things. All right, and I think that the best way to teach you guys today would be to do a video or to share my computer screen, and then basically go through a whole bunch of these and just graph the heck out of a lot of them. Because the more I graph these things, the more um, you'll be able to kind of pick up on them. Does that make sense? All right. So one of the ones I want to graph is this. Here, let me start coding stuff for you, and then you guys tell me what you guys think. All right. So what if I have f of x is equal to frac -1 over x minus 2. All right. So look at this stuff over here. This is where I want you guys to look. See that? What if I graph that? Okay. First of all, let's see, x-intercept, x-int, and then y-int, and horizontal asymptote, and vertical asymptote. All right, so all I'm doing is I'm just kind of saying, okay, what is the x-intercept? The x-intercept is when you set y equal to 0. Got it? Now, if I set y equal to 0, that's basically meaning I'm setting the f of x equal to 0, right? So, see, for the x-intercept, it's basically saying, when does this equal to 0? What x value gives you that equal to 0? So if I set f of x equal to 0, like that, okay? And then say I have a fraction, so I'm going to take everything in the denominator and multiply them by 0. That pretty much just does this. Did I lose anybody there? I just took the denominator, multiplied it by 0. And the statement that I got was 0 equals -1. Is that true or false? Is that ever possible?
No.
No.
Denominator can't
No,
equal 0.
it can't equal 0. All right. Well, no, it's not that it can't. The denominator can't equal 0. It's that 0 cannot equal -1. Always false, right?
Mm-hmm.
So I think that the point here is there is no x-intercept in this particular graph. Okay. That one was a little weird, but okay. And let me give you the hint here. The x-intercept always comes from this numerator part. Because when you set f of x equal to 0 over here, all that denominator information, basically you want to clear fractions, and so you multiply that denominator onto both sides. But if the one side is 0, then anything times 0 is just going to be annihilated. So if I had something like x minus 1 or something like that, then I would have an x-intercept. And that x-intercept is pretty easy to read off. It's just x equals +1. You know what I mean? Or if I had something like x minus 1 times x plus 3 or something like that, well, that's an easy x-intercept to read off. It's +1 and -3. I don't need to worry about that denominator, that x minus 2 thing, because remember, I'm setting the f of x equal to 0, and that whole denominator just kind of gets killed off, and then your numerator is really what governs your x-intercepts. Now, in this particular graph, there are no x-intercepts. Got it? So I should just write the word none here. All right, y-intercept. For the y-intercept, all we have to do, hey, by the way, Nanea, I have to say, you had a pretty poor grade, and I can just say that off the bat, but you did a really good job with really applying yourself and bringing your grade up. I'm going to have to just commend you in class. I don't mean to embarrass you. I don't mean to point you out or anything. I'm just saying great job, all right? Let's talk about the y-intercept. If we want to find the y-intercept, what do we do?
They're -2.
Well, you set the x equal to 0. That's what you do. For the x-intercept, you set the y equal to 0. For the y-intercept, you set the x equal to 0. Now, there is no real trick with this one, but it's actually really easy to do. I'll tell you what it is. It's 1/2. Do you see that? If you put x equals 0 here, you get -1 over -2. Positive 1/2, because those negatives canceled out. We good? So the x-intercept, y-intercept, that is not hard to find. It's not something crazy, all of that kind of stuff. Right? It's pretty straightforward. All right. And that's not even recent math. That's actually really old math, you know, from when we were doing lines. Okay. Actually, you know what? I usually find the vertical asymptotes first and then the horizontal asymptotes. Okay. So for the vertical asymptote, we're really just looking at the domain. Where is my vertical asymptote? Oh, Sophia's got it. At x equals 2. And what we're saying here is that x cannot equal 2, really. That's why there's a vertical asymptote. It's basically a line that is off limits for the graph. And then the horizontal asymptote for this particular graph, can you guys figure that out? Yes, the vertical asymptote is a line that you can never touch. The horizontal asymptote, you can actually touch it, but it will basically tend to be, towards the end, it will kind of morph towards those points towards the end. All right, and the horizontal asymptote, it's at y equals 0, because I can approximate this graph, I can approximate this to be the only relevant number on top is -1, the only relevant number on the bottom, or I shouldn't say number, but the only relevant term on the bottom is x, and -1 divided by x, we know that the horizontal asymptote of that is 0. Are we cool? So if I go to Desmos, here's what I'm thinking. I know that there's I want to graph the point, my x-intercept will be at, oh no, my y-intercept is at 0, 0.5. All right, that's my y-intercept. Got it? My horizontal asymptote, or my vertical asymptote is at x equals 2. Okay? And I think I'm going to make this a dotted line. There we go. And we'll make it red. Red means it cannot go there. And we'll make this point, we'll make it blue or green. Green is good. Can you guys see that? Is that dark enough for you guys to see? All right. And my vertical or my horizontal asymptote is at y equals 0. Right? And I'm going to, again, change this to a dotted red line. We cool? All right. So here's what my thoughts are. When I'm graphing this, I know that as I get further up this way, okay, well, here's what I'm thinking, okay? As I know that it crosses over here on the positive side, and it's going to go up to infinity over here. And then so what I'm thinking is as it goes out to the left, it's going to go closer and closer to this particular horizontal asymptote. However, it's never going to ever touch or cross the x-axis. Agreed? Would you like to know why? Well, the reason why it will never cross the x-axis is because exactly, Sophia, because there's no x-intercepts. If there was an x-intercept somewhere around here, then I would say maybe it dips down. But even if it dipped below over here, I would say that that graph still has to come back and, get closer to this horizontal line right here. Because again, a graph could cross the horizontal asymptote, but it has to, in the end, it has to veer back to being in line with the horizontal asymptote. Does that make sense? All right. Then what I think it's going to do is, as it crosses this vertical asymptote right here, I think the graph is going to start from the bottom and work its way up, and then it's going to, again, taper off. And I'll tell you what, why don't we just draw the dang graph and see what it looks like. So I had f of x equals -1 divided by x minus 2. And that's exactly what I thought it would look like, right? Isn't that what we described it would probably look like?
Mm-hmm.
And here's one of my thoughts, all right? What do you mean, how did I guess a negative? But how did you guess it to be negative? Oh, okay. You're saying that, I think what you're saying is that, here, let me turn this graph off. Let me turn everything else off, all right? And then let me just say, all right, I think that you're thinking 1 over x. That's a graph you're used to, okay? And then we know that the 1 over x, we've been playing around with these vertical asymptotes enough to know that that minus 2, all that does is pushes the whole dang thing to the right. Correct? This negative over here will flip that graph upside down.
Is it the same thing if you leave the negative on the right there?
Yeah. That negative can go right in front of that one or in front of the whole fraction. It does the same thing. But
as long as there's only one term.
Yeah.
Yeah.
But what I'm saying is there's 4 pieces of information that you can get. All right, so we did this graph through transformations, and that was actually not that hard. But there's 4 pieces of information that we can get that will help us do the graph without having to worry about transformations. The x-intercept, the y-intercept, the horizontal asymptote, and the vertical asymptote. And Sophia, the way I figured it out is I knew that the graph would look like this because of the y-intercept. Here, I'll tell you what. If this were not a negative, right here, if this were 1 over x minus 2, then what would the y-intercept be?
Negative half.
It would be negative 1/2. It would be down here, which would make me think, oh, that's how the graph would look. So that y-intercept kind of gave me a big hint as to how that graph looks. In fact, you guys are often asking me, well, where do you start? And I usually say, well, this is, I usually start with a y-intercept. I think it's a very safe place. Are we cool?
Cool.
All right, let's try another one. All right, let's try. Oh, wait, you want to see what again? You want to see that one again? Remember, I'm recording this, so you can just go back to it. Just press rewind when you rewatch it. All right. So let's try this graph right here. I'm going to graph, how's about frac 2 minus x parentheses x plus 1 parentheses, oh wait, parentheses x minus 1 parentheses x 4 minus x. Looks horrible. Okay? Where?
Negative 4.
All right. Let's get all this information right off the bat. Okay? Where are the x-intercepts? There's 2 of them.
1 and 4.
Negative 1 and positive 2.
Oh.
-1 and +2. The x-intercepts, and remember, Bradley, I told you guys that the x-intercepts comes from the numerator, right? Because I'm going to set f of x equal to 0. Usually we like to see that as a lowercase f. I'm going to set f of x equal to 0, and then I'm going to multiply out this denominator, and that whole denominator is going to get destroyed, and I'm going to end up with 0 equals 2 minus x times x plus 1. I know how to solve that. I just set 2 minus x to 0, and I set x plus 1 to 0. Bada bing, bada boom. You've got two x-intercepts, each at, one is at -2, and the other is at -1. Actually, I'm sorry, +2 and -1. Are we cool? All right. Let's go back to Desmos, and let's graph that.
-1/2.
All right, so that would be +2, comma 0. That's one x-intercept. All right, so I'm turning off all of this stuff because we're starting a new graph, and also -1, comma 0. Right? Those are my two x-intercepts. Boom and boom. Got it? I'll zoom in a little bit. We cool? All right. My y-intercept, probably going to look a little ugly. It's not that hard. All you got to do is plug in 0 here. So what is 2 times 1 times, or divided by -1 divided by +4?
Wait, -1 divided by +4?
No. 2 times 1, which
Okay.
is 2,
Yeah.
divided by -1,
Okay.
so that's -2,
Yeah.
divided by 4, so that's -1/2. Did I confuse anybody? The y-intercept. Oh, Bradley, are you saying that the... Bradley's saying, wait a second, isn't the x-intercept -2? Bradley, I want you to write down 2 minus x equals 0. And then I want you to solve for x. You'll find out that 2 equals x. Yes, I know, Bradley. I think that what's tripping you up is that you're used to seeing the x first and then the number second. Yeah, you're used to seeing x plus 1, and then you just say, oh, x is -1, or x is +1. But in this particular case, it's kind of a little bit backwards. You got to do a little bit of thinking. Not hard yet, but, thinking. All right. What is the vertical asymptote in our case?
+1 and +4. What? No.
+1 and 4.
So
1 and 4. So there's a vertical asymptote at 1 and 4. Okay, good. So I'm thinking that at x equals 1, I want a line there, and x equals 4. I wonder if I can... No, it doesn't like that. X equals 4. All right. So I want a line there and there. Let me just make this guy dotted. What did I do? Dotted. Done. Good. All right. So I've got two vertical asymptotes at 1 and 4. I've got two x-intercepts, and I have a y-intercept of -1/2. So 0, -0.5. Pretty cool?
That's trippy looking so far.
Yeah, it does look weird. All right. Let's get ourselves a x-intercept. Or not, I'm sorry, we did our vertical asymptote. Our vertical asymptote was at 2 and 4, right? No, 1 and 4.
Mhm.
All right. Now, our horizontal asymptote is at where? Okay. I can approximate this to be basically -x² over -x².
So 1.
Right? If I were to FOIL this out, the -x times the x would be -x², right? And then this x times this -x gives me negative x squared. If it's too freaky for you, then FOIL the top and FOIL the bottom, and you'll find that the leading coefficients is negative x squared for both of them. No, and negative x squared divided by negative x squared is not 0, it becomes 1. So my horizontal asymptote is at 1. That's interesting. All right, so it looks to me like I have a dot here and a dot here. It also looks to me like I have a dot here and then over here. This one's a little funky. All right, here's what I'm thinking, okay? I'm going to start at my y-intercept right here. I'm thinking that it's going to come down to infinity right over here. Got it? It's going to definitely come down to infinity over here. And then it's going to probably going to go towards this one line right here. That's what I'm thinking. Okay? Now, this one might be funky for you, but I think that the next one in the region between here and here, I think it's going to come from positive infinity, go through the horizontal axis, and then come down to, or go through the horizontal axis, go through the 2, and come down to negative infinity again. Because I noticed that over these, both of these jumps, both of these vertical asymptotes are the first degree, right? They're odd degrees. They're not an even degree. So my jump isn't going to look, it's going to be going down and then jumping from back up on top. And then I'm thinking that the graph is going to go down to negative infinity over on the left side of this vertical asymptote, and on the right side of this vertical asymptote, it's going to come from positive infinity and then head down towards that line. I'll tell you what, why don't we just graph the dang thing and see if it works? I'm excited, right? Like I want to know.
Same.
If I'm like, wow, did he get it right? Am I like that cool to be able to just kind of like look at something and then say, I think this would be the graph. And I'll be honest with you, I'm hoping that it will work. Let's see it. Ready? Boom! Look at that! Look how cool I am!
So there's actually 3?
What do you mean 3?
There's 3 separate
3 separate what?
lines.
I don't want you guys to think of these as 3 separate lines. I want you to think of these. This is all one line. Yes,
oh, wow.
there are 3.
Sections?
Yeah, maybe 3 segments or 3 pieces. All right, let's see. Ode Asteroids game. All right. Play online for free. Free asteroids. Awesome. Play game. All right, so I can. Perfect.
What?
Oh, I hit the asteroid. Okay, wait. All right. Okay, go. Perfect. That's exactly what I wanted it to do. All right, here. I'm gonna give you guys a website.
Oh.
I know it's laggy. That's why I'm giving you the website. You play on your own. Yeah, here we go. How do I shoot? Right. Let me see the instructions. Hold on. Ode Asteroids game.
Oh crud! I gotta go.
All right.
I'll watch the rest of the archive.
All right. Watch the rest of the archive.
All right. Thanks, Mr. Golding.
All right. Here we go. Play a classic game. But what's the controls? Okay. All right. So check this out. On this Ode Asteroids game, the way you play is you kind of play like this. All right. And then you're an asteroid ship that you have control over the arrows. So you guys playing this game or not? Anyway, what I really want you guys to do is go off the edge of the screen. Dude. Don't be so crazy. Oh, I killed you. Alright, there. Go off the edge of the screen. Alright. What happens is, as you go off the edge of the screen, right? Like your ship appears on the bottom of the screen all of a sudden. When you go off the top, it goes on from the bottom. Does that make sense? Yes, no? Are you guys playing? You guys aren't playing, huh? You guys are just watching me be an idiot. Alright, anyway. That's kind of the way I see these vertical asymptotes. They kind of go off into infinity down here, but as soon as it reaches the bottom of the screen, it appears at the top of the screen over here. What do you think? No. You guys should stop playing at this point. I just wanted you guys to be able to go off the screen on your Asteroids game. Alright. Now, notice that the vertical asymptote that was made, okay, over here, when I told you that when it's an odd power, it does that jump, that weird asteroid jump that we were wondering. What's so up with that? All right. When it's a square term over here, things will change, right? All of my dots are all off now. But I want you to notice what happens with this vertical asymptote. It doesn't stay. Well, yeah, it's the same exact vertical asymptote. It's still at x equals positive 1. But it's almost like it goes up and then it doesn't appear on the bottom of the screen. It comes back down from infinity. Whereas if this were a to the 1 power, it makes that asteroid jump. And that's what having that even or odd degree in the denominator does. Are we cool? Okay, and I think that what Bradley's asking is, well, what if it came from the denominator and went up? Or what if it went down and then came back up from the bottom over here? I think that maybe what you want is my graph to look something like this. Is that what you're saying, Bradley? Where it's going down to infinity and then coming up from infinity? Yeah. Well, the way I was able to, hold on. See, I don't know where to get all these new shapes are coming from, like the weird cubic in the middle. I don't know what the problem is. You're talking about this cubic function in the middle? The one on the left. Okay, you're talking about this guy, this one going down. You don't understand why it went down. Is that what you're saying? Oh, gosh. All right, hey, turn on your microphone. Turn on your microphone. Yeah, I can hear you.
Okay, so like, you see how the one on the far left goes down?
Yes.
To infinity, how do you know, like, does it come down, does it come from negative and go up to infinity and then reappear back on the bottom, or does it go down, reappear from the top, go down, and then come back around on this side? Like, how do you know?
So I think, Bradley, what you're saying to me is if I go down to negative infinity over here, how do I know, as I make the jump across this vertical asymptote, how do I know it's going to stay down or reappear at the top of the screen, like when we play asteroids? Okay. That vertical asymptote, this one over here, came from this guy right here.
Yep.
And originally, the power of that was 1 to the first power. So,
Yeah.
so what's going to happen with this guy is as he comes down to infinity like this, right? He's going to jump up across over here and make that jump. But if this power were a square term, okay, and I'm changing the sign of this graph just to kind of like appease your desire to have this thing go down. As this thing is a square term over here, that thing is going to go down to infinity, and then it's going to go. When it jumps across, it's going to stay on the same side of infinity that it started on. If I made this a cubic function up on top, let's see what happens. And that's why I think today's class is important for me to just use Desmos and play around with these things. Because what's important for us is to see what happens as we change these things. Got it? Let's make it a cubic. Okay? Then look, this is doing exactly what we thought it would, where it goes down to infinity and then comes up from infinity. In fact, I would almost say that the cubic function, or when this thing is cubed down here, it looks very similar to the graph of the when it was 1. I'll show you the cubic.
Oh, okay.
Okay, I'll show you the 1. Ready? It's the same thing. It's just a little bit less extreme.
Yeah.
To the first power. And then the cubic power is almost the exact same looking kind of graph. The horizontal asymptote changed, right? And your y-intercept actually stayed the same. But anyway.
Okay, and then I'm gonna also ask Sophia's question.
All right, go for it.
Because those ones make curves, and they feel like, I don't know. I don't want to say they make a right angle, but they make they go. You know what I mean?
Are you talking? Okay, wait. Let me go back to my original graph. This was my original graph. Okay.
So the left one and the right one, kind of, they meet at one point. Then the middle one goes. It's like a.
It's almost like
weird.
It's almost like a cubic function. In the middle?
Oh yeah, cubic. Okay, yeah. So
it's almost like an upside down cubic function, because a cubic function looks like this. X cubed, I think. There. Wait. Get rid of that. Stop showing me that thing. All right, whatever. All right. X cubed looks like this, right? The blue line.
Mm-hmm.
So that is almost. The stuff we see here is almost an upside down cubic function.
Y cubic function, and then the other ones.
Why are these parabolic and whatnot? Okay,
yeah.
Here's what I'm going to say. Remember, I'm thinking that we can get the general shape of the graph. I'm thinking we can get the general shape of the graph with knowing 4 pieces of information. If you knew the...
Oh, wait. Hold up. I think. So it has. Okay.
Yeah, that's exactly it. No, Sophia's exactly right. Is that the middle shape of the graph was governed by those vertical asymptotes?
And it has to go to the infinity, switches over, so it has to make that transfer.
Yeah.
Oh. Okay.
Yeah.
I get it.
So that's kind of what. But couldn't it just flip? What are you talking about? It could just flip. Lucas, are you saying that it could come down from the top up here and then like kiss the X, this thing right here, and go back up? Well, actually, Lucas, are you saying you want the middle of the graph to look like that? Like this? Like a regular cubic function? Okay, it couldn't be that. It couldn't be that because of this. Here's the reason why it can't be that. Because the y-intercept was down here. So I know the left part of the graph had to be this. And no one can argue with me about that. Because the y-intercept's down here and the x-intercept's over here. So I know that the left has to be like that. Well, knowing that this vertical asymptote is a first degree asymptote, right? Actually, that whole thing wasn't there. It was just delete the exponent part completely. Okay. Knowing that that's a first degree asymptote, the other side of the graph had to come up from the top and then come down and go over here. I think there's one more thing I want to play with. What happens if we did this? Whoa. What happened here? Interesting. All I did was I put a square on this sucker right here, and it really changed my graph. I wonder why that is. Actually, I know exactly why that is. We can explore that. Give me a second. I'll show you, okay? First of all, see this x-intercept? It's a square. So I would think that it comes down and then it goes off to infinity again. It kisses it, right? That's the kissing thing that we talked about, where it hits it and kisses it and goes back up. This isn't a surprise, actually, right? And then it still has to follow those vertical asymptote rules, so it comes up to infinity over here, kisses that point right there, and goes back up to infinity. Now, what's the deal with this horizontal asymptote? Because I'll tell you one thing, this horizontal asymptote that we have does not look anything like this horizontal asymptote that it's showing. In fact, the asymptote, the horizontal asymptote, and I'm using quotation marks with my fingers, is not even horizontal whatsoever. Well, here, look, check this out. If I were to apply that end behavior tricks that we use, what would this be? This would be, what's the degree of the polynomial that's in the numerator? If I were to approximate it. Cubic, good. It's x cubed on top. I agree. What is the degree of the bottom, or what's the function on the bottom? Squared. Okay, so what I have, actually it's negative x squared actually. So I have positive x cubed over, look right here, positive x cubed over negative x squared. That simplifies down to negative x. Would you agree? So my horizontal asymptote is negative x. Let me change this dotted line to make it, instead of 1, I want to make it negative x. And watch what happens. My graph tends towards those points. So I guess I explained something brand new, but vertical asymptotes or horizontal asymptotes don't even need to be horizontal. I wonder if I reload this graph, it will mix it all up. Yeah, it's a diagonal asymptote. We actually call that a slant asymptote. Anyway, yeah, it's an SA. Exactly. In fact, that's the name for it. It's slanted asymptote right there. But it's not really that crazy when you think about it. I don't know. I think that next week you guys start having homework due on this stuff, and I think that in the homework, I'll tell you what. I'll finish class. I promise. Let me just take a look at one of your homework problems. I want to see what it's like. I forgot because I wrote this homework about a year ago. What are we on? We're on. Okay, we're on RAT 4, aren't we? 1 second. Okay. RAT 4. Well, is it a good thing, or is like your head hurts or something like that? Okay, I know what I did. All right. So, oh, wait a second. Is there a problem with this one? Oh, oops. Well, I guess you guys can see me put in the answers because I'm realizing there's a problem with this question. All right. Anyway, here's what I want you to do. I don't know how to have you guys tell the computer what, like, graph something on a piece of paper and then tell the computer to grade it. Okay? Yeah, well, actually, what the problem is, Lucas, when that happens, where it says no answer text provided, is I screwed up and I actually didn't provide any answers. I think what happens is I put in the answers, but then I accidentally, at one point in time, changed it to a multiple choice question, and it deleted all my answers. So I got to redo it. So anyway, here, I'll do one of these homework problems with you. How's that? I'll do the first problem with you. Look at this graph. What is the domain issues? Where am I going to find vertical asymptotes? At 1, or at 3, right? So you can, in this box right here, you can either type in 1 or you can type in 3. And just put 1 here and 3 here and you'll be good. What is the x-intercepts? It's just 4. That's it. And then what is the y-intercept? Negative 4 divided by positive 3. So it's negative 4/3. And I'll tell you what. Yeah, negative 4 divided by 3. And then I know somebody's going to put in negative 1.3333. So I'll just try to account for everybody's answers that they put in. Yeah, that's all there. All right, good. Negative 4 divided by 3. Cool? And then, what is the horizontal asymptote of this graph? It's 0. The horizontal asymptote is 0. Actually, that's the wrong... Oh, yeah, actually, this is the right answer, right here. It's still 0. But the graph will actually look like this. You guys are thinking, what? How did you get that? Well, the reason being is because, look, there's 2 vertical asymptotes. So if the graph is going to come up like this and then probably like that. Actually, now that I'm looking at it, that does look funny as an answer. I honestly think the graph is going to look kind of like this. I'll tell you what, when in doubt, graph it and see which one's correct. X minus 4 divided by x minus 1, x minus 3. Yep. I accidentally messed up that answer. But anyway, it looks kind of like how I had it. This one right here. You got it? And this makes a lot of sense to me as far as why the graph looks like that. Because it comes down from here. It has one x-intercept. It's got a y-intercept over here. It's got two vertical asymptotes. And one of the things that it doesn't do is it doesn't cross the x-axis in this region over here. So this vertical asymptote comes down, or it is right here. And then so it comes down and then it has to go back up because it can't look like a cubic function in the middle. Because if it looked like a cubic function in the middle, it would have told me that there's another x-intercept right here. But there isn't. It can only touch the x-axis in one spot at 4. That's why it looks kind of parabolic in the middle. Are we cool? Anyway, what I'm saying is, I actually don't even know how to. If I had you guys graph this all on a piece of paper and everything, and take pictures of your graphs and upload those pictures to, your files and whatnot, I could grade this by hand, and this has never been a problem before. Except when I'm telling the computer what to do, I don't know how to have the computer get you to graph something. So what I did was I told the computer, all right, fine. I figured that if my students knew how to get all 4 of these pieces of information, the x-intercept, the y-intercept, the vertical asymptote, and the end behavior, then graphing it is a piece of cake. And that's true. Graphing it is a piece of cake if you can find those 4 pieces of information. That's why in your homework, I don't ever ask for the graph. I ask for those 4 pieces of information. Right, because those are the guidelines to those are my points of interest. Those are my guidelines to drawing the graph. I don't ever ask you to draw a graph on the computer, which is not going to be true of some of the standardized tests that they have coming up in the future. I'm sure that in the future they're going to somehow figure out a way to make you guys draw graphs on the computer and have the computer grade it or whatever. But as far as, like what I'm saying is all you need is these 4 real points of interest. On the SATs, I have to check. I think you can actually use a graphing calculator. And on the EOC exam, which is the end of course exam for Algebra 2, they actually have a built-in graphing calculator into the test. In fact, you guys know what that looks like and where it is, right? This button right here, this link in our webpage under general information says use this graphing calculator from now on. If you click on that, and I've heard that the link doesn't work as well. But I know that you don't like that one. But what I'm saying, Sophia, is that's the one they're going to give you. So if you practice on that one a little bit at least, then at least you'll be familiar with all of the buttons so that when you take the test, you'll be all right. It's going to be the same exact one. So I don't mind you using your graphing calculator. I support it 100%. When you go to college, you'll have to use that. But I'll be honest with you, all of my graphing calculators are over 10 years old and they're all broken already because the battery leaked or whatever, and I'm surviving quite well without it. It's because the technology nowadays, like Desmos, has, caught up with the graphing calculator industry, and I don't even need it anymore. Yeah, I know that it's not as simple as Desmos, but I'll tell you this, you will not have Desmos on any test you take. Unless it's a take-home test. I'll tell you what, one day I'll make a tutorial on that. How's that? All right. Anyway, I'm done with this. I'm done with chapter 4. I feel like I've really explored a lot of it. Chapter 5 is actually, I'll tell you what it is. It's really easy. Chapter 5 is just doing the same thing we did, but backwards. In fact, all of the problems I did for you today actually came out of chapter 5. What I did was in chapter 4 what we did was we were given the equation and we're asked to graph the thing. In chapter 5 I'm going to give you guys the graphs, and then I want you to find what the equation has to be in order to make that graph. So you're still using the same techniques, you're just now applying them a little differently. And I honestly think that the best way to get good at this stuff is just to do a lot of it. That's probably why I'm giving you so much homework on it. All right? All right. I went a lot over time, like 18 minutes over time. I apologize profusely, but I feel like we had a good conversation. I hope you guys learned something. I hope that was interesting. I will stop the thing. I will upload. Did I upload Wednesday's archives? I don't remember if I did or not. Awesome, Bradley. And since you're on another island, I don't have to worry about biking on the streets while you're driving. Yeah. Yeah, well, you're on a different island, so don't kill anybody, but I'm just saying. All right. Um, any questions? Class is over. You guys can leave. Did I make any mistakes on anything? Is there any homework assignments where I screwed up? Yeah, you guys sent me a question about Rat 7, or question 7 on Rat 3, page 1 to 3. Let me take a look at that right now. And we'll just knock that one right out. Okay. Yeah, Sophia emailed me about that one. Hold on. This one is going to have a horizontal asymptote at 1. And so the answer should probably be something like, why? It's this. It's this right here. Right? Okay, fine. Let me investigate it further. It has a horizontal, or it has an x-intercept at -3. Ooh, I think I found my mistake. Is it this one right here? Yeah. All right. Yeah, you're right. Because -3 is the x-intercept that's right there. Boop. You guys got it. All right, so I'm going to award points for both corrected and previously correct answer. No scores will be reduced. Update that. Okay. Oh, good, and it looks like it told you guys how to. I mean, and also it looks like you figured out how to do something, which is good too. We're cool. All right. Talk to you later. Okay, bye. Hey, Nanea, you're hanging out still. Are you still there? Okay, cool. I was just wondering, since everyone's gone, do you need any help with anything? Are you good? Okay. All right. How did you catch up so quickly? Did you just kind of sit down and watch the videos and figure it out? Okay. See, I feel like the thing is, I know that you're incredibly smart. And I know that if you had the time to dedicate to this, you could probably do really well. And I have 3 children, and I understand how crazy it is.